Alright, so today's notes is going to be on acceleration. Table of contents. I went ahead and added acceleration. Go ahead and just put in your page number. Alright, so let's go ahead and start. Alright, so let's go ahead and write the word acceleration at the top of your page. Okay. Alright, it never hurts to repeat what acceleration means. Acceleration is going to be the rate of change in velocity or direction. And of course the formula for this alright, and the formula for this is going to be delta V over T. Alright, so before we move on to some new stuff, right, let's go ahead and look at some old stuff that we did yesterday. Okay. Alright, this graph, right? So, you can always just flip back to it. I just had to bring it over here so that you can see it. I'm going to go ahead and label some parts. Okay? Let's see what's going on. Right here. Is this accelerating? Is the velocity changing right here? Right? Because acceleration is what? Rate of change in velocity. Well, from 0 to 1 second, is it moving faster? If you said no, you're correct, right? It stayed at 2 meters per second. So this has no, I'm just going to put A. Alright? Next, we have this part down here. It's also flat. So does this have acceleration? No, right? No. A. Alright. Just quick peek over here. Right? This part has no acceleration. This whole thing is going at 2 meters per second. Okay? So since it's constantly 2, no acceleration. Okay? This is also no acceleration. Well, let's look at here. Again, it's a flat line, right? So this is also no acceleration. This one's a little bit special, right? There's no acceleration here, but what's going on? It's not even moving, right? So this would be no acceleration and no motion. Can't see, I'm going to zoom in. No motion, no A. The last bit is over here. Okay? This velocity looks like it's actually increasing. So let's see how much the velocity increases by. Rise over run. So it's rising by 3, and it takes 3 seconds, right? Actually, so I'm sorry, it rises by 2 and runs 3. Okay? So, sorry about that. Alright, so the rate of change, it's accelerating, right? Remember, acceleration is delta V over delta T? Why is it change focus so much? Alright. So, our delta V is 1, 2. And what's our time? 1, 2, 3. Okay? So our acceleration is equal to 2/3. we probably won't have to calculate too much acceleration here, so let's just say it is accelerating. Alright, let's go back. So, now that we got that done on the graphing part, let's go ahead and see how does velocity, acceleration, and motion combine, right? How are they related to each other? So I'm going to go ahead and write several columns. It's going to be velocity, acceleration, okay, motion, try to make motion the biggest column because I'm going to draw a picture for it, okay? I love pictures. Alright, so let's go ahead and get started. Grab color. So, remember we talked about this? If we didn't, I'm going to go over it again. Right? There should still be some room up here, or I'll just even put it up here. You can put it by the title. In physics, going up and to the right is positive. If you go left or down, it's negative. It's just like that thing in math, you know, the coordinate plane, right? If you go up and to the right, it's positive, left and down is negative. Same thing in physics, okay? Okay, let's go ahead and get started. Velocity, so let's say velocity is going positive, to the right, or up, right? Let's go to the right. Acceleration is also going to be positive. So I'm going to draw a little car under my motion. Alright, so it's already moving in the right direction. Remember, positive is right. Here we go again, to the right, positive. Acceleration means someone's pushing on it or something is making it go faster, right? But since acceleration is to the right also, they combine, right? So it's going to be speeding up. Next, what happens if velocity is negative and acceleration is negative? Well, let's see what happens there. We have a car. It's going to the left. Right? Oh, sorry, it's going to the left. And acceleration is going to the, so someone's pushing it to the left. So what's happening to this car? Speeding up or slowing down? If you said speeding up, you're a genius, right? Should be speeding up. Next, what if I did positive and negative? Here's my car. Where's it going initially? To the right or left? To the right. Exactly. Good. To the right. Okay? But acceleration is negative, so that means someone's pushing it to the left. So is this thing speeding up or slowing down? You said slowing down. You are correct. So if you see what's going on, you can go ahead and move on. Try to figure it out yourself. If not, go ahead and follow along. Next, we have a negative velocity and a positive acceleration. So I drew my car, right? My Hot Wheels. Now let's just say it's a Lamborghini, okay? Alright, so velocity is to the left, acceleration is to the right, exactly. So is this slowing up or speeding up or slowing down? Should be slowing down. Alright, what if velocity is, doesn't matter, plus or minus, and acceleration is 0? Well, let's see. I have a car that's driving, but acceleration is 0, right? So is anything pushing on it? Is it slowing down or speeding up? No. So there is no change. We'll see later in physics, this is inertia, right? An object in motion stays in motion. Okay? Next, what if velocity is 0? So I'm going to go ahead and just fill the rest in, and then if you can figure out the rest, great. Plus, minus, and then 0, 0. Alright, so let's do this one first. Okay? So velocity is 0. So I'm not going to draw an arrow on top. It's not moving. But acceleration is going to push it from the left or right. Doesn't really matter, right? Let's just pick a side. Let's pick left. So what's happening to the motion? Exactly, it's speeding up. Okay? But where's it speeding up from? From rest. Last one, we have a car. No arrows, not moving, no velocity, no acceleration, nothing's pushing on it. So it is at rest. Alright. Everyone good to go? Let me just leave it there for one more moment. Alright. Let's go ahead and get started on practice problems.